Welcome to this video for Year 11 Maths Methods, Exercise 2F, where we're going to look at families of straight lines. So, families of straight lines are simply collections of lines that share something in common, but also have things that change between lines. Those things are what we call parameters. So, let's have a look at what is involved in this particular exercise. So, a family of straight lines basically involves a couple of things. Number one is a parameter, and number two is something that stays fixed. So let's look at a very simple example to start us off, y equals mx. So if you take the equation y equals mx, there's a couple of things we can notice straight away. We know that any value before x, which is m, is the gradient. And if you think about what the y-intercept is, well, we can't really see it straight away, but if you think of the plus 0 that's kind of invisible at the back over there, that is going to be our y-intercept. And that is why the equation y equals mx represents a family of straight lines that pass through the origin, because that is your y-intercept, and they also have what we call varying gradient. So that varying gradient is basically shown by something called a parameter. So if you've never heard the word parameter before, it simply represents a property or a number that changes. So property, number that changes. So what that means is we've got a whole family of lines, which is y equals mx. As the gradient, which is m, as that value changes, you will keep getting a different member of the family. So think of the family as the collection, and each specific line is what we call a member of that family. So as you can see on the right-hand side, I've got 4 lines drawn there. Y equals x, y equals 3x, y equals negative 2x, and y equals half x. As you can see, all of them share something in common, and that is the y-intercept at the origin, but they all have differing gradients. In fact, I've actually got something drawn on calculator to help you see this even further. So let's look at the first one. Here is y equals x. It's a straight line with a gradient of 1, and it also passes through the origin. Next, we have y equals 3x. Similar thing, passing through the origin, this time gradient of 3. Next one, we have y equals negative 2x. So here we have a negative gradient, but still it's passing through the origin. And finally, we have y equals half x. So looking at all these members of the family on one graph, you can see that they all share the common property that their y-intercept is the origin. However, each of them is unique by its gradient. Excellent. So moving on to the next one. So this time we have y equals mx plus 1. So with y equals mx plus 1, what's going on here? Well, again, m is going to be your gradient, but this time we have a fixed y-intercept of 1. So y-intercept is going to be at 0, 1. So this is very similar to the previous example. However, this time our y-intercept is 0, 1. So again, as you can see, the description of this family is that the y-intercept is always at 0, 1, and of course the gradient varies. So yet again, we've got a parameter where the gradient is the one that is changing. So let's look at that one on the CAS. Again, here we go. The first line is y equals x plus 1, gradient is 1, y-intercept is also 1. Next line, gradient is 3 and y-intercept is 1. Next one, gradient is negative 2 and y-intercept is 1. And finally, the gradient is a half and y-intercept is 1. Looking at all of them together, we've got our fixed y-intercept at 0, 1, and we've got our various gradients. Excellent. So there are 2 instances where the gradient is the parameter. Well, the gradient is not the only thing that can be a parameter. You can also have the y-intercept be the parameter. Okay, so let's look at this one here, y equals 2x plus c. So in this particular case, our gradient is the one that's fixed, that's constant. So our gradient is going to equal 2. So every member of this particular family will have a constant or fixed gradient of 2. And on the other hand, we've got the y-intercept that keeps changing. So the y-intercept is going to be our parameter. And that is why we see all this family is described by a fixed gradient of 2, but the y-intercept is the one that varies. So that is why our parameter is the y-intercept, which is c. Okay, let's look at this on the calculator. All right, so here we go. Here is a gradient of 2 and y-intercept of 1. Here is a gradient of 2, but this time it's a y-intercept of -2. Here is a gradient of 2, goes through the origin, so the y-intercept is 0. And finally, we have a gradient of 2 and a y-intercept of 3. As you can see, we've now got 4 lines over here, all with the exact same gradient, which means, by the way, that they are all parallel and they have different y-intercepts. So 4 lines, same gradient, different y-intercepts. That is our family. Okay, so that is just a quick description of what a family looks like. Let us now go ahead and actually move to some examples. So let's look at the first example. A family of lines is defined by the equation y equals mx minus 3. So part A says, what property of this family is the parameter and what property is fixed? So the best way to do a question like this is identify what you know about the line. This is in y equals mx plus c form, and that's why we know that the gradient is m and the y-intercept is -3. So our gradient, well, that's just m. So I'll just write gradient. So gradient is equal to m, and our y-intercept is equal to 0, -3. In other words, the parameter is the one that's changing. So this is our parameter. And what property is fixed / constant? It's the y-intercept. So we're going to call that fixed. There we go. So this is a family that has a varying parameter as well as a fixed y-intercept. Okay, part B. Now this is where we get down to some actual maths. A member of this family passes through the point 4, 5. Find the value of m and hence state the equation of this line. So we're talking about a specific member. So remember, a family is a collection of infinitely many lines, but if you talk about a member, something is fixed. You basically fix the value of m and then you've got one of the members. So what is unique to this member? Well, this member of the family passes through the point 4, 5. So we need to do 2 things. We need to, number 1, find the value of m, so I'll call that number 1, and hence state, so remember we have to use hence, state the equation of this line, and that's number 2. So we have 2 questions to answer here, and let us go ahead. So what we're going to do is we're going to take the point 4, 5 and plug it into the equation. So the equation is y equals mx minus 3. So how we're going to do it is we're going to replace y with 5 and x with 4. So that is all you have to do. Simply replace x and y with the respective parts of the coordinates. Now that that's done, let's simplify this equation. M times 4 is just 4m, minus 3 remains as it is. Let's add 3 to both sides to get 8 equals 4m. And this finally implies, after you divide both sides by 4, that m is equal to 2. Let's just write that again. M is equal to 2. So we've answered the first part of the question, which is find the value of m. So now we need to hence state the equation of the line. Therefore, so the equation of the line, the equation of the family, is y equals mx minus 3. However, we have found this specific member of the family has a gradient of 2. And that is why the equation of this particular member is y equals 2x minus 3. So all you got to do is go back to y equals mx minus 3 at the very start of the question, look at the value of m that you've just found, which is m equals 2, and plug that in, and you get y equals 2x minus 3. And there you go, that is our answer. What you could do is you could even go to your calculator, type in y equals 2x minus 3 into it, and then you'll be able to see that it certainly goes through 4, 5. Excellent. Let's move on to our second example. So this time we've got a line with equation y equals kx plus 2. So very similar to the previous example, but this time the gradient is k rather than m. Not a big difference, just a different letter. So what we're saying is a second line is perpendicular to this line and passes through the same y-intercept. Okay, so I'm just underlining the main parts of this question. So we have perpendicular and also has the same y-intercept. So it's probably a good idea to write out what the y-intercept of the line is. So we have y equals kx plus 2. So clearly, if that is in mx plus c form, the y-intercept is at 0, 2. Okay, so we've got a y-intercept of 0, 2. So what that means is this second line is perpendicular to the original line and also goes through the point 0, 2. So what we have to do is write the equation of the second line in terms of k. So we've got the original, so the original gradient is going to be k. Where did I get that from? Well, remember, the coefficient of x is k, so it means the gradient of the original line is just k. And therefore, the gradient of the second line, so I'll just say m second, the gradient of the second line here, there you go, second, so the gradient of the second line is going to be, you need to do the perpendicular. Remember what that means? Flip the fraction, flip the sign. So we have k over here, which really is just k over 1. So flipping the fraction, it becomes 1 over k, and it's positive, so you flip the sign, and it becomes negative. So what we have is our second line has a gradient of negative 1 on k. So therefore, its equation is y equals negative 1 on kx. And do we know the y-intercept? Yes, we do. It has the same y-intercept as the first line, and that is simply 2. There we go. Y equals negative 1 on kx plus 2 is the equation of the second line, and it's also in terms of k. So the in terms of k part simply means that you see k somewhere in your equation. Right, moving on to part B. The second line passes through the point 12, 5, and we have to find the value of k. Okay, so this is very similar to example 1b, where we're given a specific coordinate. So again, what I'm going to do is I'm going to take that coordinate and plug it into the equation from part A. So let's plug that into y equals negative 1 on kx plus 2. Right, let's work out what this involves. So I'm going to replace y with 5 and x with 12. So negative 1 on k multiplied by 12 plus 2. Subtracting 2 from both sides and then also simplifying the fraction. So 5 minus 2 is 3, and negative 1 on k times 12, that's just negative 12 over k. So the best way to solve a question like this is let's get rid of the fractions by multiplying both sides by k. So we end up with 3k equaling negative 12, or in other words, this implies, after dividing both sides by 3, that k is equal to negative 4. Okay, so this specific member of the family goes through the point k equals negative 4. There we go. That is the second example done. Let's move on to our very last example. Okay, this one is a bit trickier than compared to the previous ones, but just pay attention with what is going on here. Understand each step, and it's not too bad. So, a family of lines has the equation y equals mx minus 6, where m is greater than 0. So, we have to be careful over here. We've got a family of lines over here with a varying gradient. So the gradient is the parameter, and the y-intercept is fixed at negative 6. But you need to pay attention to something very important. It says that m is greater than 0. Now that will be clear later on why we need the gradient to be positive. but for the moment, just keep that at the back of your mind. So what does the question want? It says, find in terms of m. Again, you see this in terms of a phrase over there, which is very important. It says, find the coordinates of the x-intercept of this family. So you want the coordinates of the x-intercept of the family. So we don't want the x-intercept of any one particular line. You actually want a general expression for the x-intercept of any of the lines described by the family. It says, hence, state the values of m for which the x-intercept is at least 3. So what this is saying really is we've got a whole bunch of lines and we want the x-intercept to be more than 3. Okay, so let's have a look at what this deals with. So how do we find the x-intercept of a straight line? Well, it's quite easy. You simply have to write x-intercept, comma, y equals 0. So this is something that you know already from previous studies. We're just doing the same thing again. So x-intercept y equals 0. 0 is equal to mx minus 6. Okay, so our job is to isolate x. Let's add 6 to both sides. 6 equals mx. And finally, we want x, so we're going to divide both sides by 6. So x would equal 6 over m. So therefore, what this means is the coordinates of the x-intercept, remember the question wants the coordinates, is going to be 6 over m, comma, 0. Okay, so remember that if it wants coordinates, you have to give coordinates. The other part of the question did say in terms of m, and certainly we have actually got our coordinates in terms of m, because you see an m right there at the bottom of the fraction. Perfect. So that is our x-intercept. Now, the second part of the question, state the values of m for which the x-intercept is at least 3. So we want the x-intercept basically to be at least, not 0, at least 3. Okay, so at least means greater than or equal to. So this is very important. So what we now need to do is take that x-intercept, which is 6 over m, and make it greater than or equal to 3. Now this is a bit of a strange inequality. It's not something that we can do easily by hand, so we're actually going to use our calculator to assist us with this. So we're simply going to solve the inequality. 6 over m is at least 3. So we're going to go to menu, then 3, then 1 for solve, and then control fraction, 6 down m, and then tab, and then at least. So control equal, and go to the bottom one, which is greater than or equal to 3, and then comma m, and hit enter, and there we go. So we end up with 0 being less than m, less than or equal to 2. So what that means is m needs to be greater than 0, but at the same time it needs to be less than or equal to 2. So let's go ahead and write that out. So 6 over m is at least 3. So therefore, 0 less than m less than or equal to 2. This can also be written in interval notation if you prefer. It's the same as m is an element of 0 not included, comma, 2, but 2 is included. So what that means is as long as your gradient is positive and it's also less than or equal to 2, your x-intercept will always be 3 or more. So this is basically our answer. Either way is acceptable. And I remember back to the part where I said m is greater than 0. Well, you can see that happening right here. M is basically at least 0. So it can't be a negative number. Right. So, well, let's see what this means on a graph. So y equals mx minus 6. So let's go here. Let's add a new graphs page. So y equals m times x minus 6. I'm going to create a slider for m, and here's what I'm going to do. We know from our answer that m has to be between 0 and 2. Okay, so if m is equal to 0, for example, you can see it's a flat line, which makes sense. gradient of 0 means flat line, there's no real x-intercept going on there. And that's why 0 is not included in our answer. Let's try something a bit different. Let's say 0.5. Okay, well 0.5, you can clearly see this line is going all the way. It's even exiting the screen. I believe the x-intercept for that would actually be 12. So 0.5 is somewhere between 0 and 2. The x-intercept is 12, which is definitely more than 3. Now let's go to m equals 1, for example. Here we go. M equals 1. That x-intercept right there is simply 3. I'll show you what I mean. Analyze 0, left, right, and there we go. So the x-intercept is 6, 0. What happens, let's say, at maybe 1.5? Okay, at 1.5, we've got an x-intercept which looks like it's at 4, and m equals 2, which is the largest m value we can have. That is the x-intercept of 3. So we can see just from that, that quick go through of the different values of m that certainly we get an x-intercept that is at least 3. Now let's try something that's a bit more. Let's say 2.5. Okay, this time we've got an x-intercept that's slightly more than 2, but less than 3. Unfortunately, that does not correspond with what the question wants, and that is why you can see that m equals 2 is the largest possible value of m to get an x-intercept of at least 3. Excellent. So that is pretty much how this goes. That's exercise 2F done. So make sure you've understood these examples. If you need to go over any other part of the video, by all means skip back to it and watch it again. Otherwise, any questions, please ask. Make sure that you have a go at the questions, and all the very best. See you next time. Bye-bye.